So in this video, what I wanted to go ahead and start talking about are solids of revolution. Now, that's going to be one of the big things that we're talking about over the next couple of lessons are solids of revolution. Now, hopefully the one thing you're picking up on is it's got to be a 3D figure and it's got to involve some form of rotation. So let me go ahead and start off by giving you a very quick definition of what a solid of revolution is. Number one, it has to be a 3D figure. And that 3D figure is going to be made by taking some curve, a two-dimensional shape, either using x-axis or y-axis. Doesn't really matter which axis you use. Again, it's just a 2D curve. And what we're going to do is we're going to take that 2D curve and we are going to rotate it. Again, either over the x-axis or the y-axis. It doesn't really matter. So notice again, I've got that same curve. That I drew in 2 dimensions. And what I'm doing is that I'm, in this case, rotating it around the x-axis. I'm taking it and I'm rotating it into 3 dimensions so that it looks like it's got that same symmetry, top, bottom, front, back. It's going to be this same curve all the way around. Now, based off of this kind of information, I want to go ahead and make sure I mention some real-world examples, some places where we would see solids of revolution in our real life. So let's start off with a very, very simple one. I've got right here one of these Little Debbie cupcakes. And so notice a couple of things important to point out is notice in this case, my axis of revolution is actually going to be going through the top and bottom of this cupcake. It's going to more or less be on the y-axis. My curve is going to be this curve that starts at the bottom, kind of comes straight across, and then goes along the edge and comes back. And so that's the thing, is this edge is the plane curve. And what happens is they rotate it all the way around so it gets this nice symmetry to it, okay? And that's how we get the solid revolution. But one of the things I want you to pick up on it is notice the circular base. Same kind of circles, top and bottom. Now notice they don't have to be the same size. One of them's bigger, one of them's smaller. But neither way, we have a circular base to it. Now, based off of that, I want to go ahead and show you some more. I've got this nice speaker right here that is also a solid of revolution. Again, if I look at it, it's got this axis of revolution that goes through the top and through the bottom. It goes right through the center. Nice pretty cylinder here. What they do, again, follow the edge all the way down, and that's going to be your curve. And again, we just rotate the curve into 3 dimensions, still circular bases. All right, let me keep going. I got a few more. This bucket right here, again, I know I keep kind of showing you some of the similar ones, but notice what's different about this. This, instead of being straight along the edge, it's got these little dimples in it. So I can still use curves to simulate this edge right here, even this little rim to it. I can use a curve to simulate all of these rims and try to actually make it work out nicely. I can even simulate it so that it's the exact width of this this bucket, and so that I can find the volume of what's inside the bucket, or I can find how much metal made up the bucket. And so it's one of those things. I can actually use curves to simulate the edge of this bucket and then rotate it into 3 dimensions using my, again, I'll say y-axis as its axis of rotation. So let me go ahead and switch over and talk about this nice little fan here. So here is my 2-dimensional curve, this almost trapezoid looking shape, because it's kind of fatter at the top and a little skinnier at the bottom. In this case, my axis of rotation is right here, and what's happening again is we're going to rotate that 2-dimensional curve into a 3-dimensional shape, okay? So let me repeat again. This is my axis of rotation. This is my 2-dimensional shape, and I'm rotating it so that it becomes a 3-dimensional object. I've got one more quick example that I'll show you in person is this Expo marker. Again, I can use the x-axis here as my axis of rotation. I can use a curve that comes across, kind of dips in for the tip of the marker and comes back out for the cap. I can use a curve to simulate this edge, and then it gets rotated into 3 dimensions, okay? Again, you're still noticing the circular bases. I've got 2 more examples that I drew because I didn't actually bring them to school today. Is number one, most flower bases, again, as long as they have a circular base, are solids of revolution. You can use a curve to simulate the edge of the vase, and you can, again, rotate it into becoming a 3-dimensional figure. Another one are jars or lots of containers. Again, if they have a circular base, then you can use a curve to represent the edge of that surface and rotate it until it becomes a 3-dimensional object. Again, circular bases. So hopefully that helps you understand, again, what a solid of revolution is. We're going to come back and do some examples more of this in just a few minutes.